So in today's application problem, the question is asking what would be the length of the hydrogel if it was stretched to its fullest capacity? So we want to know the length of the hydrogel after stretched. And stretched to capacity means stretched as far as it can go. What do my numbers represent? So the hydrogel can be stretched to 21 times. That's how far it can be stretched. How far hydrogel can be stretched. And then 3 2/10 represents the length of the strip of hydrogel. So that is the original length of the hydrogel. So to find out how long it would be after we stretch that piece to capacity, if it starts out at 3 2/10 and it stretches to 21 times its capacity, we're going to multiply 3 2/10 times 21. Now, there are a couple ways we can do this. We can use our area model. We can use the standard algorithm. I'm going to start by using the standard algorithm. So I'm going to cover up the tens place on the bottom, and I'm going to start with my ones place on the bottom. 1 times 2 is 2, and 1 times 3 is 3. And remember, yesterday we learned that zap and 0. And now I'm going to come over to the 2 that's in the tens place. So 2 times 2 is 4, and 2 times 3 is 6. I'm going to add those partial products together. 3 and 4 is 7, and 6. So now we have to place our decimal correctly in the product. So we count the number of times that decimal moves in the factors. It moves 1 time there, so it's going to move 1 time here. The answer is 67 2/10 centimeters. You could also have solved that with your area model. We could put 3 2/10 on the top and then decompose 21. 1 times 3 2/10 is 3 2/10. 20 times 3 2/10. So 2 times 2 is 4, and 2 times 3 is 6. And remember, we're multiplying by a 10, a multiple of 10, but our decimal moves over, so that answer is 64. So now we add those two partial products, just like we did here, and there is your answer.